Okay, so today, Monday, January 27th, we are discussing angles. We're going to talk about supplementary angles, complementary angles, vertical angles as well, and kind of some simple problems just about them so you kind of get your head wrapped around what exactly they are. So the first thing I want to talk about, though, is how to properly read and write an angle. Okay, so let's make angles notes. Okay, so part one, how to read / write angles. Okay, so one way you'll see angles presented is you'll be given an angle of some kind, and it'll have a letter named at the vertex, like Q or whatever, right? Any kind of letter, right? And then we would call this, we would write out, hey, this is angle Q. Now, this symbol here is indicate angle whatever. So it's kind of like an L shape. It's, but it's a little bent over. It's not a greater than sign or less than sign or anything like that. It's just it simply kind of looks like an angle, That's the idea. So anyway, you'll see that symbol a lot to reference angles. But another way you can see an angle presented is, let me make a generic one with 3 letters here. Let's call this one QRS. Okay. So the way you would write an angle like this is angle QRS, and it's got the 3 letters, and it's going in a specific order as well, QRS. It's indicating, start at Q, go to R, then go to S, so that it's telling you it's kind of between these 2 lines, right, from Q to R to S. And the reason we have to be that specific rather than just saying, hey, if we're talking about this angle, why don't we just say angle R? You have a good point on that example, but the reason why you're going to see this a lot and why the order is so important is because we'll have angles that look like this. Let me add one to this. Let's call this one A, B, C, D. So you're going to have angles like this. And if I just said angle B, right, you don't really know what I'm talking about, because am I talking about the entire angle? Am I talking about the angle as part of this wedge or this wedge? It's kind of hard to say. So that's why we have to be more specific about these 3 letters indicate, well, which particular angle am I talking about? So for example, let me use a different color. If I want to indicate this angle, this wedge, right, then I'm going to say angle ABC. Oh man, trying to erase just the purple part. Anyway, you get what I'm saying? Okay, I'll just redraw it. It's fine. Right, but we'll have to say for the purple wedge part, right, if I want to say just this angle, I would have to say angle ABC. And again, I'm going in that order, ABC. The middle letter here is going to emphasize the vertex being, of course, the point where the angle resides. A and C are sort of going to be the end lines or the edges, but the vertex B is in the middle. So you can't say, angle BAC. It's got the same letters, but it's not the right order around, because if you put it in this order, you're indicating A is the vertex point of the angle, and A is not the vertex point of the angle. Angle B is the vertex point of the angle. So, but you could say angle CBA. This would be fine because it's referencing the same angle, kind of in a backward sense, but it still has B in the middle as its vertex. So either of those would technically work. I think typically, though, you would kind of do it alphabetically, but technically, they're not wrong. Okay, but there's more than that here. What if you saw, let's use a light blue here. What about this wedge, right? Well, this wedge would be angle CBD, or if you want to reverse it, DBC. So we're talking about that angle. So CBD references the wedge between those lines, between the lines CB and BD. So again, you can write it backwards as well, as long as you're indicating, the vertex point B in the center. But there's even more to this than that. So like, let's use green, right? What if we reference this entire wedge? What if we want the whole thing and not just the slices themselves? Well, that would indicate, from angle A, B, D. You're saying here to here to here. You're emphasizing that entire wedge when you say those 3 points. So, of course, you can say it backwards as well, D, B, A. So the 3 letters is helpful because there are essentially 3 angles that are hiding here around angle B. And the 3 letters help us identify which wedge we're technically talking about. So make sure you can read and write these angles properly. It's going to be very, very important. Of course, remember the order is going to matter a lot. The value in the middle has to be where the vertex point is. For that green wedge that I just did, you wouldn't be able to say angle, DAB, because then you're saying, something like A is the vertex point, A is not. So it has the same letters, like we get that, but it has to go in order. All right. So next up, we are going to discuss the 2 types. Two types of angles that we'll see: complementary and supplementary angles. So we'll start with complementary angles, and also supplementary angles. Now, you may have heard these before, but maybe you forgot what they are. So let's kind of remind you. So complementary angles are a pair of angles. It's important, the word pair here, because it indicates that it's just a set of 2 angles, not 3 angles, 4 angles, anything like that. It's just 2 angles, no more than 2. Well, okay, so a pair of angles that add to 90 degrees. So again, it's just a couple of angles, a pair of angles, 2 angles only that add up to 90 degrees. Supplementary angles are similar in the fact that they're also a pair of angles, only 2. But these add up to 180 degrees. Now, just so you're understanding this, 90 degrees and 180 degrees. 90 degrees is a right angle, okay? Something like this. And you'll see it kind of noted with the little square there. The little square there is telling you it's 90-degree right angle. If you just see a little line like this, it doesn't really indicate it's 90 degrees. But if you do see a square inside here, inside that angle, then that does indicate a 90-degree angle. A 180-degree angle is simply just a straight line, essentially. If you want to think about the vertex, it's rotated around completely backwards 180 degrees. So if you just kind of imagine this ray and then taking it and rotating it 180 degrees, then the ray would be pointing the complete opposite direction. So it looks like a straight line. So if you have a straight line, that's technically a 180-degree angle. So there's no special little symbol like the square here for complementary. For the 180, there's a special symbol for 180, but it is just a straight line. So if you do see a straight line, you know it's going to be 180 degrees. So let's practice some math here with some complementary and supplementary problems. So let's go with complementary first. So remember, these are a pair of angles that add up to 90 degrees. So if I have a pair of angles, now notice the little square I put in there for the angle that's indicating to us that it's 90 degrees. If I say that this angle is 63 degrees, let's give these letters. Let's say this is E, F, G, H, right? So angle EFG is 63 degrees. What is angle GFH? Well, because we know that the 2 angles here add up to 90 degrees, and we know they add up to 90 degrees because the little square here is telling us that this is a right angle, that it is a 90-degree angle. If I was able to combine this angle with the one down here, they would add up to 90 degrees. So since I know it adds up to 90 degrees, all we need to do is just take 90 and subtract the 63 that we already have, and the remainder, the leftover amount, will be the size of this angle here. So 90 minus 63 is 27. So that means it's 27 degrees, GFH. So GFH is this angle here, this wedge that we didn't know the size of. So let's do whatever. Let's do something similar to it. So let's try W, X, Y, Z. So let's say that we have this angle, it's 20. No, let's not make it 20. Let's make it 18 degrees. All right, so we have angle X. No, sorry. We have angle Y, X, Z. And again, notice the order there is very important. X is the vertex there of that angle, so it's the center letter. YXZ, angle YXZ is 18 degrees. So what is angle WXY, which is this other wedge? So, I got to draw the most important symbol. The little square here, remember, is reminding us that it's a 90-degree angle. Without it, there's no way to know it's a 90-degree angle. So you'll see that on every one of these complementary problems. It has to show you that to tell you it's a 90-degree angle. So if it's a 90-degree angle and that one wedge is 18 degrees, then just take the difference again, right? So 90 minus 18, this ends up being 72 degrees. So 72 degrees is the answer for this other wedge. Okay. Now they do get a little bit more interesting, a little bit harder. So let's do one more right angle one more complementary one. We're going to call this, let's see, J, K, L, M. So this one, I'm going to say that this angle is x plus 15 and this angle is 2x plus 15. So we're going to find three things here. First thing is find x. What is x? Then we're going to find the size of angle JKL. We're also going to find the size of angle LKM. So that's the two wedges. Now, how are we going to figure out what these sizes are, right? Well, you have to remember that the two angles add up to 90 degrees. So even though I don't know what the values of them specifically are, I do know that if I take what I have, 2x plus 15, and I add it with the x plus 15, right? I take both angles and I add them together. I know that they would equal 90 degrees in total, right? So I am taking them and adding them up together to equal 90. It's just I don't have really numbers yet for it. But that's fine. I can just I can set up an equation like this, and I'm going to solve the equation. I can figure out what x is. And that will help me out later. So this is going to help us find x. So here we just need to combine like terms. So like terms, we have our x terms. We have 2x and 1x. When I combine 2 and 1, that makes 3. So that's going to be 3x. We also have other like terms. We have 15 and 15. We can combine those as well. 15 plus 15 makes 30. So we have 3x plus 30. And this, of course, equals 90. So now, again, we've combined like terms. We just solved the equation. So subtract 30. We have 3x equal to 60. And then we divide by 3. We end up with x equal to 20. So this is not our angle size, right? X is 20. We know that. Not 20 degrees. X is just simply 20. Now, if I want to find the angle, let's say JKL, let's do that one first. JKL is the angle, remember, 2x plus 15. Right? JKL is the 2x plus 15 angle. Now, since I know x is 20, I can simply plug this in and find out how big that angle actually is. So 2 times 20 makes 40, and 40 plus 15 makes 55. So that angle is 55 degrees. This one here is 55 degrees. The other angle, angle LKM, is x plus 15. But remember, we found out x was 20, so we can plug that in. We have 20 plus 15, which is 35. So there we go. X is 20, but the two angles are 55 and 35. And if you want to just quickly double check, 55 plus 35 does indeed equal 90. So that confirms that our work is accurate, because remember, it was supposed to add up to 90 the whole time. So the other thing we talked about is supplementary angles. So supplementary angles, same concept, but they add up to 180 degrees. So you'll notice these because you'll see a straight line. Like right there is a straight line, 180 degrees. I'm going to split it into two angles, this left angle and the right angle. Now I'm going to give you one of them. I'm going to say, let's say that this angle is 52 degrees, right? Let's give these letters as well. Let's say A, B, C, D. So we know that currently angle CBD is equal to 52 degrees. But I want to find angle ABC. Well, remember, it's just like complementary, but instead of adding up to 90, these actually add up to 180. So if the two angles together add up to 180, and 52 degrees is already one of the angles, then just find the difference, right? If we find the difference, then we can find that the size of the other angle. So 180 minus 52 degrees ends up being 128 degrees. So that's how big this other angle would have to be, 128 degrees. Of course, if you add them up together, right, you have 128 degrees plus 52 degrees, then you have 180 degrees, which makes that straight line. So it's just the same. Just take the difference, and you can find your answer. So let's try another one. So here we'll do RSTV. So let's say I have this angle is 109 degrees. Okay. So we know that angle TSV is equal to 109 degrees. Then let's try to find out the angle of RST. Remember, the two angles add up to 180. So if we just take the difference between 180 and 109, and we find the remainder, 180 minus 109, we get a result. Now this should be 71. So RST is 71 degrees. So this is 71 degrees. All right. And now one more supplementary, but let's make it a little more mathy. Let's say we have, let's use JKLM again, JKLM. Let's say this is 3x plus 65, and let's say this is 4x plus 10. So it's the same issue we had with the complementary problems before, this one up here, you know. We are going to find three things here. First, we're going to find out what x is, because we can't do anything unless we know what the value of x is. So we're going to do that first. Then we're going to find the angle sizes. So we're going to find angle JKL, and then we're also going to find angle LKM. So first, let's find x. Now, to do that, remember, we have to understand that because this is a straight line, a straight angle, that it's a 180 degree angle. So that means the two angles here, the 3x plus 65 and the 4x plus 10, those two angles should be added together and equal to 180 degrees because it makes that straight line. So that's how we set up our equation. That's where we go to start solving it. So combining like terms like before, you have 3x and 4x. We can combine those. And we have 65 and 10. We can combine those. Now 3x and 4x, that makes 7x. And 65 and 10 makes 75. So we have 7x plus 75 equal to 180. So now, again, just a regular equation to solve. 7x equals 105. And divide by 7. And x is equal to 15. So we found x. X is 15. Now we can use that to find the size of the other angles. We want to find angle JKL, which was 3x plus 65. We can just plug that 15 in for x. So 3 times 15 plus 65. This comes out to 45 plus 65, which means this is 110 degrees. If we want to find the other angle, LKM, there's actually two ways you can do this. If you already know the other angle is 110 degrees, then you could just find the difference between that and 180. So 180 minus 110, which is 70 degrees. So this should be 70. But you can also, if you want to just reassure yourself, take the x value again and plug it in. So 4 times 15 plus 10. 4 times 15 is 60. 60 plus 10 is ultimately 70 degrees. So it confirms, right? 110 plus 70 is equal to 180. So you can double check just to make sure. And then one more thing I want to discuss is vertical angles. I don't know what exposure you have to vertical angles before. So vertical angles are this. Let's give a definition. Definition, where did I write my definition? Okay, so a pair of opposite angles made by two intersecting lines. So what that looks like is, let's draw a line, right? That, right? Just a plain old line, and draw another line that's intersecting it. So there's a line that's intersecting it. So vertical angles are the pair of opposite angles of these intersecting lines. So these pairs of opposite angles, for example, here, that pair of angles, those are called vertical angles. And a side note is that these are congruent angles, meaning that they're the same size angle. But there's also another pair of vertical angles. It's the other side. So it's, this side here and here. The top and bottom side, those are also vertical angles because they're opposite angles and they're congruent. So everything's congruent here. But that's what vertical angles are, is they're opposite sides, opposite angles. So you have two pairs here. You got the one illustrated with the blue. You got one illustrated kind of with the green. So if we do a little bit of a math problem with it, just real quick to finish this video off, let me draw another pair of vertical angles. And let's say, well, let's put letters here. So let's say this is, for simplicity's sake, just A, B, C, D, E. So let's say this angle here is 48 degrees. Okay. So angle ACB is equal to 48 degrees. Then let's see if we can find out angle DCE. So angle DCE is the opposite side. It's this side. And since we can tell that these are vertical angles, we know that that side must also be the exact same measurement. It must also be 48 degrees. But we can even find out more than that. What about angle BCD? That's the angle up here. Well, it's not 48 degrees because it's not the opposite angle of the 48. But we can still figure it out because, let me sort of use another color here. Because this angle, the one that we know is 48 degrees, and the BCD angle that I'm referring to, these are supplementary angles, meaning that those two angles add up to 180. So if those two angles add up to 180, then I can do exactly what I did with the supplementary angles before and just take the difference. So if I did 180 and I subtract the 48, I end up with, what is that? 132 question mark, I think. So I can do the math, supplementary angles, and understand that this angle up here is 132 degrees, which of course means this angle opposite of it would also be 132 degrees. So angle ACE would also be 132 degrees. So vertical angles are helpful because they kind of tie in with supplementary angles as well, and they give us a lot of information about the lines that we see. So keep them in mind because we're going to see them a lot moving forward. That's going to end it for the video here. I hope it's useful to you. I hope you learned something, and I'll see you in the next one.